All right, guys, welcome back to COSC 1437. We're looking at chapter 3. We're going to look at how to format output using the method printf. So let me share my screen. All right, so this is printf. And so far, we've been looking at using print and print line. With printf, which is actually a method that came from C programming. So if you've taken C programming, if you've seen it, you'll see it there. And we're going to still use system.out, but we're just going to attach printf. And then we're going to have a string in quotes, or you can have the string in quotes plus your arguments, which would be like your variables or some kind of calculation. So I have a little program over here that I want to just show you, kind of show you how this works. So we have system.out.printf, and this is the number that I want to display, the 10. So there's several options that I have to use here to display this 10. So one of my options is that I can tell it what column to begin the end of my number, so the 0. So what I'll do here is I'll do system.out.printf, and I'm just going to print 1, 2, 3, 4, 5, 6, 7, 8, 9, so that you can see. So you can see where the 10 is aligned, okay? And so if I run this, what this first statement does is the 5 in front of the D, it's going to, oh, I need a new line. Give me just a second. So to get my new line, I'm going to put in, one option is %n for new line. Okay, so if you look down here, let's not look at the name Joe, but let's just look at the 10. Notice the 0 starts at 5. Give me a second, my dog wants to go out. Of course. Okay, so the 0 starts at column 5, and then working backwards, it's going to align. So it's right aligning, right? Right aligning. If my number was bigger than 5, then it just adjusts. So it doesn't cut off anything or truncate. So if, let's say, my number is 105, 6, 7, 8. So it's 6 digits. It's not going to truncate my number. It will just start at column 6. Okay. So if I just do %d by itself, and let's just keep the same number, run it, then it left aligns. So if I don't put the number in front of it, then I'm not telling it what column. So no number here, meaning I'm going to left align. If I put a number like this 5, it means that I'm going to start at column 5. And again, if I do %n gives me a new line. So let's run this again. Oops. And then you'll see I get a new line after 1, 2, 3, 4, 5, 6, 7, 8, 9. I get a new line after printing 105, 6, 7, 8. And then I start on column 5, printing Joe. So there's the 5 right there. There's column 5 there. That's where Joe starts to print. Now, %D is if I want to print numbers that do not have floating, just non-floating point values. S is for strings. C is going to be if I want to print a character. If you look in your book on page 131, it has a table like this that gives you all the different specifiers. So %S is for string, %C for character, a D is going to be for integral or integers. E, if we want a floating point number that's formatted as a scientific notation. F is for floating point numbers. N is for a new line. So let's say that I had this number and I wanted to format it to 2 numbers after the decimal. So I'm going to put 0.2, which means 2 numbers after the decimal. I'm not putting a number before that point, 0.2, so it's just going to be left aligned. And then I'll put F because it's a floating point number. So 0.2 there, meaning I want 2 numbers after the decimal. And notice that it rounds. So 10.57 was rounded from 10.5678. Okay, so that's floating point numbers. And then characters is just the C. Now let's say that I wanted to print a percent. Maybe this is the percent, 10.57%. So if I want to print a percent, let's say at the end here, let's put some spaces so you can see it. So by the way, any spaces that I add here are spaces that are going to print out. So if I do percent, and then %n, and right now it doesn't matter that there's a space there, you're not going to be able to see it because there's nothing printing next to it. Oh. Let me find. Isam! Hold on 1 second. I'm sorry. Of course, the second I start to record, all kinds of things happen. Okay, so in this example, I want to print the percent sign. So when I run it, it prints a percent because I put 2% signs right there. Okay. Now, if I put a space after F, remember I said earlier that if you put spaces in there, they actually print out. So if I do that, then I'm going to have all this space here before the percent because I put spaces in here. So even though it looks a little bit hard to read, you can't have spaces because they will get printed to your output. Okay, let's take a look. Let's go back to the PowerPoint to see if there's anything that I missed. So we looked at the argument list. So the argument list is separated by commas, unlike the print line and the print, we had the plus signs. So you can have variables or expressions or constants. In my example, I had constant. This is a constant, this is a constant, but I could have a variable or I could have an expression like 10 plus 30. Each one of the arguments is going to be separated by a comma. So for example, if I want to print Joe and I want to print the number 50, then I just put a comma, and then here I'm going to put, maybe I put some spaces, and I put percent D to print the 50. So each of the arguments needs to have that specifier, and it needs to have the commas to separate. So there's Joe, and then 50, and I just put some spaces in here, and that's why there's some spaces before 50. So this example, it's saying this only has a formatted string. In this one, we have, it consists both of the format string and the argument list. So the format string is everything in quotes. That's the format string. And then the arguments is, here's one argument and two arguments. Arguments are separated by commas. This here is what we call centimeters, is your variable. This here is going to be your expression. So you're calculating something. Percent .2f and percent %d are called format specifiers. So percent .2f is matched with the first argument, which is this expression here in our previous example, and percent %d is matched with centimeters. So if we go back, this here will get matched with this calculation. So I'm going to get two numbers after the decimal, and then this one is going to get matched with this. I'm sorry, not that. That's the new line. This one, percent %d, will get matched with that. Percent %n positions the insertion point at the beginning of the next line, so it just gives you a new line. The option width is a decimal. Oh, so that we talked about the width, and that goes in front. And let's see, there's an example of using width. I think they have one. But I was showing you earlier that if I put a number like here, 5s, 5 would be the width of my space allotted to have Joe printed out. And so this is a way that I can write a line, everything on my page. The option precision is a decimal integer usually used to restrict the number of characters. So if you want a certain number of characters, oops, we can do that. And then required conversion is a character indicating how the argument should be formatted. So here's what they mean. So if we look at this here, so they're saying the required conversion is a character. So this is the character here. A, S, C, D, E, F. Those are the characters. And it indicates how the argument should be formatted. So if I have an S, it's telling the system format it as a string or format it as a character. So these are the specifiers, which are the supported conversions in Java, and those are in your book on page 131. So again, this is to use if you're going to output a string, if you're going to output a character, output an integer, scientific notation, floating point number. If you want to output the percent sign, just put 2%, and this is a new line. This is an example of how the scientific notation would look like. So if you have the number 35.45, there's an output. So fixed decimal notation looks like this. So 2 numbers after the decimal. And then scientific notation would look like this when you output the values. And all you have to do is, the difference is, one, you use F just to have 0.2F, 2 numbers after the decimal, display as just a floating point number. And here you have %E. So %E is going to show the values as scientific notation. So if you want to type this program and test it out, you can. Here's an example of using, so we have pi, radius, and height. So 2 decimal places. So this is showing you how we can print 2 numbers after 2 decimal places, 2 numbers after the decimal, 3 numbers after the decimal. So this is 0.3, 3 numbers after the decimal, 4 numbers after decimal, 0.4, and then 5 numbers after the decimal. So here's what it would look like, 12, 12.000, like that. All right. This is another example in your book. So here we printed 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, just so you can see what column everything falls on. So %5, remember that we're going to start column 5. And D means I'm going to print an integer. Num is an integer. And N means give me a new line. Here again, I start at column 5. I print 2 numbers after the decimal. I'm printing rate. Oops. The next one, I start at column 5. And I'm printing num. So the first thing I print is num, 96. And then I print, I start at column 6 from here. So starting here, I go 1, 2, 3, 4, 5, 6, and print rate, which is 15.50, 2 numbers after the decimal. In this example, they just added a space here to show you that that space would actually show on the screen. This is just yet another example of using printf, except this one is using a string. So you can take a look at that. Again, string, you can do the same thing. You can tell it what column to start on or not. Just looking to see if there's anything different or weird here. Everything looks pretty normal. So in this example, notice that there's a minus sign before 5D. So let's take a look at this one. So here we print 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 through 9. So it prints a big number like that, just so we can see what column we're on. And then the first thing is it's going to print the number 7 num, and num is 763. So let's see if we can figure out what's going on here. So we know that 5 means a column, like I want to start at a certain column, but I started on the left side, right? But notice there's 2 spaces here. Oops, wrong way. And then it says 7.2 and X is 1, 2, 3, 4, 5, 6. So this has 6 numbers. So what the minus is doing is it's giving me the 5 spaces, but it's going to left justify. So the minus means left justify, but give me 2 empty spaces on the right. So instead of having 2 empty spaces on the left, you have 2 empty spaces on the right. And the only reason I have 2 empty spaces is because this number is only 3 digits long. Same for this one. It's going to give me 1, 2, 3, 4, 5, 6, 7. So it's left aligning because it's -7 and then 0.2, meaning 2 numbers after the decimal. So this negative in front of the column width is give me that column, but left align. No minus sign, then give me that column size, but right align. Parsing numeric strings. A string consisting of only integers or decimal numbers is called a numeric string. So this here is a numeric string right here. This is a numeric string. To convert a string consisting of an integer to a value of type int, we use the following expression: integer dot parse int string expression. So if I do this, this is no longer a string, it's now an integer, and I can take that value and use it in calculations. So why does that matter? Or where could we use this? Well, let's say that I have somebody entering input, and they're entering input into some text box, and I'm grabbing the data, it's just text. Then I can parse it and convert it to an integer and then manipulate it, like use it to add or subtract or do some kind of calculation. So integer would be the class and parse int would be the method. We can also do it with floats. So float dot parse float and doubles. Oops. Integer, float, and double are classes. They're designed to convert a numeric string into a number. These classes are called wrapper classes. Parse int is a method of the class integer, which converts a numeric integer string into a type integer, which is what we said earlier. Parse float is a method of the class capital F LOAT, and is used to convert a numeric string into an equivalent value of type float. Parse double is the method of the class double capital D. Okay, so we're going to stop there because I want this video just to be about formatting data. So try it out. You're going to be required to format some data for this next lab. Thank you.